In this lesson, we're going to be reviewing least common multiple. Then we are going to use what we know about least common multiples and apply that to adding and subtracting fractions that have unlike bases. First, let's review what least common multiples are. In order to add and subtract fractions with uncommon bases, you need to find the least common multiple of the denominator. So let's review how we do this. To find the least common multiple of 2 and 8, you want to start by listing the multiples for each of those numbers. Our multiples of 2 are 2, 4, 6, 8, 10, 12, 14, and so on. We're just going to start by listing the first several. Our multiples of 8 are 8, 16, 24, 32, 40, 48. So between these two lists, we want to find the smallest multiple that the two have in common. The smallest multiple in common is 8. So our least common multiple, I'm going to do that in a different color so we can see that. Our least common multiple equals 8. For number 2, finding the least common multiple between 3 and 5. So starting by listing our factors or our multiples of 3, 3, 6, 9, 12, 15, 18, and 21. And then listing the first several of 5, 5, 10, 15, 20, 25, 30. Then comparing the two lists and finding the number that they have in common, the smallest one they have in common. Our least common multiple between 3 and 15, or 3 and 5, is 15. 15 is the smallest multiple that they both have in common. So our least common multiple equals 15. Finding the least common multiple between 8 and 10. Our multiples of 8 are 8, 16, 24, 32, 40, and 48. Our multiples of 10 are 10, 20, 30, 40, 50, and 60. And then again, comparing these two lists and finding the smallest number they have in common. The smallest multiple that 8 and 10 have in common is 40. So our least common multiple equals 40. Now finding our least common multiple comes in handy when we are finding or when we're adding and subtracting fractions with unlike bases. So this is a process that eventually you're going to want to be able to do with mental math. But for now, writing out those multiples is perfectly fine and a great way to show your work. Go ahead and highlight 3, 4, and 6. Now let's take a look at how we can apply least common multiples to adding and subtracting fractions with unlike bases. So the steps are very similar, but there's a couple of extra steps when our bases are not the same. First, you still want to write your mixed numbers as improper fractions. So you want all of your fractions to be either proper or improper when adding or subtracting. Then you want to determine the least common multiple of your denominator. So again, this is for when your denominators are not the same. Once you've determined that least common multiple, you're then going to rewrite the fractions using that least common multiple. And when we rewrite it, the denominator changes, so we must also adjust our numerator to reflect that change. Once we've done this, after this step, you should have common denominators. Your base should be the same. Then you would add and subtract your numerator, making sure you keep the denominator the same, and then simplify if needed. Remember, with fractions, we always check to see if it needs to be simplified. So let's take a look at how we can apply these steps to a few examples. Number 7, 11 over 9 plus 2/3. First, we want to make sure that everything is written as a proper or improper fraction, and both of these fractions are. However, both of these fractions have different bases, 9 and 3, so we can't add these as they are. So what we want to do is we want to apply step 2. We want to first determine our least common multiple. So remember, we want to list our multiples. So our multiples of 9 are 9, 18, 27, 36, and 45. Our multiples of 3 are 3, 6, 9, 12, and 15. So comparing these two lists, we can see that 9 is our smallest number that they have in common. So our least common multiple is 9. And we're going to use that as our common denominator for our problem. Well, if you notice, our first fraction already has a denominator of 9. So we're going to leave that fraction alone. We're going to keep it 11 ninths. Plus, now we need to rewrite 2/3. So because that denominator is changing, so must our numerator to keep the value the same. So we know that our denominator is going to be 9 because that's our least common multiple. So in order to change our numerator, we want to consider how many times does 3, our original denominator, divide into our new denominator, 9. 3 goes into 9 3 times. So then we're going to multiply that 3 times our numerator. And 2 times 3 gives us a new numerator of 6. So again, we determined how many times our original denominator divides into our new denominator. Then we multiplied that times our numerator. And that gives us a new numerator that is equivalent to our old numerator. Now that we have like bases, we can add our numerators. 11 plus 6 is 17, and our denominator will stay the same. So 11 ninths plus 2/3 is 17 over 9, which cannot be simplified. But it can be written as a mixed number. 9 will divide into 17 one time with 8 left over, and the numerator stays the same. So our answer is 17 over 9, or 1 8 ninths. Let's take a look at another example. Number 8. Both of these, again, are proper or improper fractions, so there's no need to change them. However, both of our bases, 4 and 7, are not equal. So we need to find a common denominator using our least common multiple. So listing our multiples of 4. 4, 18, or 4, 8, 12, 16, 20, 24, and 28. And then listing our multiples of 7. 7, 14, 21, 28, 35, 42. Now comparing these two lists, we can see that our least common multiple, the smallest number they have in common, is 28. So we're going to use 28 as our denominator. The two original fractions have denominators of 4 and 7. So we're going to need to rewrite both of these fractions. We know that they're both going to have a denominator of 28, so we can go ahead and set it up, leaving out our numerators. In order to get our numerators, we need to, like we did on number 1, determine how many times our denominator of 4 divides into our new denominator of 28. 4 goes into 28 7 times. Then take 7 times your numerator. 3 times 7 gives us a new numerator of 21. For our other fraction, 7 goes into 28 4 times. 4 times 9 is 36. Now that we have our common denominators, we can simply add our numerators. 21 plus 36 is 57, and our denominator stays the same. So 3/4 plus 9/7 is 57 over 28. Or we can write it as a mixed number. 28 will go into 57 2 times with 1 left over, and our denominator of 28 stays the same. Let's take a look at another example where we have a negative number. So again, both of these fractions are written in a proper or improper form, so there's no need to change them. But the two denominators are not the same, so we do need to rewrite the fraction with equivalent fractions that have a common same denominator. And we're going to do that by listing our least common multiples. So starting with our denominator of 6, our multiples of 6 are 6, 12, 18, 24, 30, and 36. Our multiples of 8 are 8, 16, 24, 32, 40, and 48. Comparing these two lists, we can see that the smallest number that they have in common is 24. So we can say our least common multiple equals 24. And we can use 24 to rewrite our fractions so that we can add them. So I know that my denominator is going to be 24. So I can go ahead and set it up, leaving room for my new numerators. I also know that my first fraction is negative. So I'm going to go ahead and place my negative sign above where my numerator is. Now I need to calculate what the new value of my numerator will be. Taking my old denominator of 6 and determining how many times does 6 go into my new denominator of 24. 6 goes into 24 3 times. 6 goes into 24 4 times. Taking that 4 and multiplying it by my original numerator, 4 times 5 is 20. Then, looking at my second fraction, my original denominator is 8, and 8 will go into my new denominator of 24 3 times. And 3 times my original numerator of 3, 3 times 3 is 9. Now that I have common denominators, I can simply add my numerators. Remembering we're adding with a negative, so negative 20 plus 9 is negative 11, and your denominator of 24 stays the same. This cannot be written as a mixed number, and it cannot be simplified. Make sure that you're paying attention to that negative sign and remembering your rules or your methods to adding with negative numbers. Let's take a look at number 10. Number 10, we do have an improper fraction, but then we also have a whole number. So we want to rewrite that one so that they're both fractions. So remember, any whole number written as a fraction, we just simply put it over 1. So we're going to rewrite that problem as negative 12 over 1 plus 7/5, so that we're dealing with both fractions. But we still need to make sure that we have a common denominator before we can add them. So I'm going to list the first few multiples of 1 and 5. My multiples of 1 are 1, 2, 3, 4, 5, 6, 7, 8. My multiples of 5 are 5, 10, 15, 20, 25, 30. Comparing these two lists, the smallest number that they have in common is 5. So I've determined that my least common multiple equals 5. I can use this least common multiple to write my common denominators. So I'm going to rewrite my fractions where they both have a denominator of 5. And I know my first fraction is negative, so I'm going to go ahead and place my negative sign so I don't forget it. Then I'm going to determine my new numerator. Taking a look at my first fraction, my numerator of 1, or my new denominator of 1, goes into my other denominator of 5 times. So we're going to multiply our numerator times 5. 12 times 5 is 60. Our second fraction already has a denominator of 5, so my numerator is going to remain the same, 7. Now that my denominators are the same, I can simply add negative 60 plus 7. Remember, when you're adding with a negative, depending on which method you use, whether you're using the rule, the model, or the number line, that 60 is negative. So we don't add like we typically add with positive integers. Negative 60 plus 7 is negative 53. And our denominator stays the same. This improper fraction can also be written as a mixed number. Writing it as a mixed number does not change the fact that it's negative. 5 will go into 53 10 times, with 3 left over, and our denominator is the same. Go ahead and highlight number 11 and 12. And then highlight 13 through 18. Let's look at how we can apply this to a word problem. Margie has 4 2/5 pans of lasagna. After a party, she has 1.5 pans left. How much lasagna was eaten at the party? So first we need to determine what math operation should I do in this problem. We have a whole pan of lasagna and then you eat some, so you're taking some away. So this is a subtraction problem. So we're going to be subtracting 4 2/5 minus 1.5. Just like we talked about with like bases, these two mixed numbers need to be written as improper fractions before we can subtract them. To change our first mixed number, 4 2/5, to an improper fraction, 5 times 4 is 20. And then 20 plus 2 is 22/5. Minus our second fraction, to write that as a proper fraction, 2 times 1 is 2. 2 plus 1 is 3. And remember, our denominators stay the same. So we're going to be subtracting 22/5 minus 3/2. Well, our bases need to be the same. And right now, they are not, 5 and 2. So we want to list our least common multiples to determine, or we want to list our multiples to determine the least common multiple. So my multiples of 5 are 5, 10, 15, 20, 25, 30. My multiples of 2 are 2, 4, 6, 8, 10, 12. Comparing these two lists, I can see the smallest number they have in common is 10. So my least common multiple equals 10. So 10 is going to be my new denominator. So I'm going to go ahead and set up my problem where I have a denominator of 10. And then I'm going to determine my new numerator. Looking at my first fraction, 22/5. 5 will go into 10 2 times, and 2 times 22 is 44. My second fraction, 3 halves, 2 will go into 10 5 times, and 5 times 3 is 15. Remember, if you are changing the value of your denominator, the value of your numerator also has to change. Now that I have like bases, I can subtract. 44 minus 15 is 29, and our denominator stays the same. But remember, because this is a word problem, and in the word problem they used mixed numbers, we want our final answer to also be a mixed number. So we can convert 29 over 10 to a mixed number. 10 will go into 29 2 times with 9 left over, and our denominator stays the same. So she will have 2 9/10 left. Taking a look at number 20, Brett ran 3.5 miles on Tuesday, 2 1/3 miles on Wednesday, and 5 3/4 on Thursday. How many miles did he run all together? So remember, that word all together tells us we're going to be adding in this problem. Number 21, what is the difference in height between a rose bush that is 3 feet 9 inches tall and Emma, who is 5.5 feet tall? So first, we need to determine what type of problem it is. It asks what is the difference, and the word difference tells us to subtract. The other thing I'd like to point out is it's talking about 3 feet 9 inches. So we have to convert that to a fraction. 3 would be our whole number. 9 is our part out of a whole of 12 inches. So 3 feet 9 inches can be written as 3 9/12. Or if you'd like to simplify that, you can simplify that fraction also. Number 22. An empty fish tank weighs 4 2/3 pounds. Once filled with water, it weighs 29 1/4 pounds. How much water was added? So you're trying to find the difference between the weight of the fish tank before and after. So this problem would be a subtraction problem. Go ahead and highlight number 20, 21, and 22.